The next step is to define the setFL words method here that is called an initialize method. So it's a void method. And the first thing we need to do is we need to create the two arrays that we declared above. We need to allocate some memory to them. And let me repeat the comment here just to remind you what is actually stored in those two arrays. So we know it's a two-dimensional array, but what is the size? Well, if it's indexed by I and R, the size of the dimensions should be the number of sentences and the number of references per sentence. And the same for class. And remember that those two data members are inherited from the parent class, and their values have already been set, so I can use them. And what we do now is we have a basic nested for loop that goes through the sentences, which are indexed by I, and then for each sentence goes through the references, and we'll index them by R, and both of these indices are 0 based, and you just have to set the contents of those two arrays somehow. Okay. And you should do that using the reference translation, which is already available to you here. Okay, so this element of the ref sentences array stores the rth reference for the ith sentence, and it's a complete sentence as a single string. So how would you extract the first word of this and the last word and store them here? Well, the easiest way would be to split it up wherever there's a space. So split is a method defined for the string class in Java, and you just take the resulting array and store it in this array, and then simply the first word, the first element in that array is the first word, and the last element in that array is the last word, which is indexed length -1. Right. And we are done with this method. So this method will basically set the contents of those two data members. The next step is arguably the most complicated step of this process, which is where we actually get to compute the sufficient statistics for a given candidate translation. So we have this method which returns an array of integers, which are the sufficient statistics, and it takes a candidate translation as a string, and it will return to you the sufficient statistics that you get by scoring this candidate against the references for the ith sentence. So you take a candidate translation and you score it against references that correspond to the ith sentence, and you should return the sufficient statistics. And this does exactly what you would expect it to. It creates this array, and at the end returns it. And the code we have to write now is the code that actually sets the contents for that array. Well, the contents of the array depend on the first word of the candidate translation and the last word, so we probably should extract those before we do anything. And to do so, we will use the same trick we just saw, where we take the candidate string, the string of the candidate translation, and split it into words, individual words. And then we extract the first word of the candidate translation, which is simply the first element in the array. And we extract the last word, which is the last element in the array. And for each one of those two, we should compare them to the first words of the references. So we should check to see if FW, the first word of the candidate, matches the first word in any of the for any of the references. And to do that, we just go through the appropriate elements in the array that we just created and set here. Right? So you need to compare FW, you can use equals for that, against the first word of the ith of the rth reference of the ith sentence. So first ref words sub I sub r. Right? Well, if they're equal, what should you do? You should probably increment some kind of count and then break out of the for loop, because you don't want to check the other references. And this count, which we should declare, probably, it starts at 0. And then if you find any match for the first word, you increment that count and then you break. And you do the same thing for the last word. You should check to see if there's if it matches any of the last words of the reference translations. And at this point, once you get here, the value of count is somewhere between 0 and 2. Well, what you do with it is you just stick it in. You just stick it as the first element in the stats array, with the second element of the stats array being simply 2. If you remember the examples that we saw in the beginning of the first part, where we computed the statistics for a candidate, there's simply 2 values, the count and then 2. And then you return that array because you're done with it. And this basically is it for this method. Now notice, if this is arguably the most complicated step, and I say it's the most complicated because it captures the essence of your metric, and it was still that easy, well, it was straightforward, then that's a good thing. And really, if the metric you're implementing, if you're familiar with it and you know exactly how to implement it, and you're familiar with it, with how to implement it, this shouldn't be too much of a problem for you. And the last thing we should do for this class is to define this method called score, which takes an array of sufficient statistics and returns the score calculated based on those values. So it has there's this double that it declares, and then it eventually returns, and you should write the code here that actually computes that value. The first thing in this method just makes sure that the length of of the array here matches the expected length. So just leave this as it is. You don't have to worry about it. Well, we defined the FLM metric to be the ratio of the 2 values in the sufficient statistics array. So that's exactly what we do. We take the ratio of the 2 values and just make sure that one of them is cast as a double. And that's it for this method, and that's it for the whole class. Actually, we're done with this class. There's a last step here, 9b. This is actually optional. This method, you don't actually have to write anything for it. This is useful for debugging purposes, and you can read more about this in the documentation, but you don't have to write this. Z-MERT doesn't need this method. And you're actually done with this class. And the final step before you use it is you have to add exactly 3 lines of code to evaluation metric, where you tell it, hey, there's this new metric that inherits from you. And figuring out where to add these lines and what to write is really straightforward. You just need to follow the pattern here. So here's the first method that ties in the name of a metric with with the length of the options array. So blue expects 2 options, so you're tying it with 2. 0, 1 lost doesn't have any options. And as we saw for FLM, it also didn't have any options. You recall that is the length of the array passed into the constructor. So that's the first line. And then the second line is adding a branch in this if-else block that ties in the name of a metric with the name of a class. And you just need to add a branch for the FLM metric and just tell it that the class corresponding to it is called first last match. The FLM metric, whatever. And you're done. Once you're done with this, you recompile the code, and now you're ready to run Z-MERT with the new metric.